Today is the 17th of January 2024, and this will be our 33rd video on some possible questions, and they are all past papers. So far we've only looked at the calculator paper, okay, and we've looked at higher questions that have come in the calculator paper. Now, thank you everyone who have subscribed to our channel and who are following us. Okay, if you haven't considered already, please can you consider subscribing and following us, okay, on which platform you are using us, watching us from. I will appreciate that. And please, when you watch it, share it. If you like it, don't write it in my inbox. Like it and give us some nice comments. I would really appreciate that, okay? And if the account is not yours, please do ask permission from the account holder. It's very important. I write please follow my notes/scripts, okay, in the comment section, because at times, for instance, this is 9 and that is 4. So if I go ahead of myself and I'm talking about 4 are blue, okay, and I'm pointing at 4 and you hear 9, please go by 4, okay? Thank you very much. Beware of scammers, okay? Today I have a lot to do, so yeah, just beware, okay? Beware. If you've not heard me say anything, it's not coming from me, okay? Don't assume. Beware. Watch last video for recap, okay? Now today I'll start at the last video. I went through some of the questions, past papers, and I saw similar probability questions. So I decided to revisit the probability question from the last video, okay, just to emphasize on what we've learned, because probability questions are easy, but at times students don't want to answer them, okay? So I'll in the few videos I might just use the starter to solve these questions, okay? A bag contains 9 sweets. Yesterday we saw counters. Today they have 9 sweets. So it can be 9 anything, 9 fruits, 9 balls, 9 anything, and then 4 are blue, okay? So if it is 9, the total is 9, your numerator for the first instant will be 9, okay? So if you are going to pick a non-blue sweet, your probability will be 5/9. And if you are going to pick the first blue sweet, your probability will be 4/9. Okay, so let's keep that in our mind. Okay, 2 sweets are taken out of the bag at random. Again, you were not given the picture, I just drew something, so I have dots, 4 dots to represent my 4 sweets, and then one, we are not told whether they just said 4 are 9 and 4 are blue. So it can either be that the others are green, yellow, or anything. So I use different colors because in the end you have 9 sweets. Okay, so because the question is about blue sweets, I didn't need to know whether the other ones are red or green. All I need to know is that in total, every all the sweets in the bag are 9. Okay, so if I pick a blue, first instant it will be 4/9. If I pick a non-blue, first instant it will be 5/9. Okay, so keep this at the back of your mind. 2 sweets are taken out of random. Okay, so you are going to pick twice. Okay, so find the probability that at least 2 of the sweets are blue. So at least means you can pick first instant blue, second instant blue. Okay, you can also go in and pick first instant blue, second instant non-blue. And then you can go, it can also be that the first one was non-blue and the second one was blue. Okay, we looked at this question yesterday, but because I've seen similar questions, I decided to bring it. Here, the sweets are 9. It can be 7 sweets. It can be 11 sweets. Whatever they are, the first pick will be over 9. So the second pick will be over 10. Okay. Now, we want a probability of at least one of the sweet picked is blue. Okay, so we have 4 blue sweets and 5 non-blue sweets, as you can see here. They are similar, so you can't cheat. Now, our picking option of at least 1 blue sweet is first instant 2 blue sweets, second instant first instant 1 blue, and another instant the second option 1 blue, or 1 blue, 1 non-blue, or 1 non-blue, 1 blue. Okay, so now the probability of picking a blue sweet will be 4/9. Okay, because you have 4 in the bag. So if the first pick, if you pick the first one and it's a blue, that will be 4/9. If you pick the first one, the first one, and it's a non-blue, that is 5/9. Now, if you pick the first one, the second one, and it's a blue, now you have 8 in the bag and 3 blue, so it will be 3/8. If you pick the second one and it's non-blue, now you have 8 in the bag, and then you had 5 non-blue, so it becomes 4/8. Okay, now if you pick the first one and it's non-blue sweet, it will be 5/8. The second one and it's a non-blue, it will be 5/8. Okay, because you have still 5 non-blue, but you've already picked the blue, so it will be 5/8. So your options will be 4/9, okay, where your first peak is a blue, 5/9, where your first peak is a non-blue, 3/8, where your second peak is a blue, 5/8, where your second peak is a blue because it's reduced by 1, or 4/8, where your second peak will be non-blue. Okay, so here you've picked non-blue, so it's the non-blue reduces by 1, and then you have 8. Okay, you want at least the outcome should be at least one should be a blue. So the first instance to pick 2 blues, so I'm going to pick the first one a blue, 4/9, and then I went back again. The second instant I pick another blue, so I'm left with 3 blues and 8 balls. That will give me 12/72. Okay, my second instance, I went in and I pick a non-blue. Okay, so picking a non-blue, okay, no, I picked a blue, so I have first one blue, okay, so I have 4/9, and then second one a non-blue, so I have 5 because I have 5 non-blue. I've already picked the blue, so I'm left with 8, so that will be 20/72. Third instance, okay, I went in, I picked a non-blue, 5/9, and then I went back again and I picked the blue. After picking the first one, I'm left with 8. Now there are 4 blue balls, so I've picked a blue now, which is 4/8, which is 20/72. So now I have 3 instances where I'll pick 2 blue balls, first, second, first blue, second non-blue, okay, and then first non-blue, second blue. So 20/72 and then 20/72. Okay, because I'm picking twice. Okay, so now if I add all those 3 instances, first one, first blue, first pick blue, second pick blue. Another instance, first pick blue, second pick non-blue. Okay, each time you pick, the total reduced by 1. So in the first instance, it's 9. Okay, 4/9 for blue, 5/9 for non-blue. Immediately you pick 1 out, it becomes 8. So if you go back in and pick another one, it depends on what you picked first. Okay, so if you pick a blue first, then now your probability will be 3/8. But assuming you picked a non-blue first, your probability will become 4/8. Okay, for the second pick, because if you are going back to do a second pick, then you have 8 balls. Okay, so you have to add 12/72, 20/72, and 20/72. If you add the numerator, 12 plus 20, 32, plus 20, 52. The denominators are the same, so 72. So 52 over 72. If you have, then you get 26 over 36. And then you have them again, you have 13 over 18. So even if they are 11 in total, your denominator will be 11 for the first peak. Then the second one becomes 10 for the second peak. Okay, now here the clue is at least you need to pick out one blue in total. So that's why you have to find the three options and add them together. So your answer will be 13 over 18. Now, we all know that from the videos we've done earlier, probability always add up to 1. Okay, so it's either, instead of picking at least one blue, the other option is you end up picking at least one is a non-blue. Okay, so I can have 1 minus the first peak, 5 over 9, which is picking a non-blue. So now I have 8 in the back. The second peak of a total of 8. Of a total of 8, I'll have 4 over 8. Because now I've already picked that. Okay, so this is 20 over 72. And then I'll subtract that from 1. Because if I'm not going to pick a blue and all my 2 picks are non-blues, then I can take that probability out of 1. And whatever I get is the probability of picking at least a blue. Okay, so now in place of 1, I'm going to put 72 over 72. We did something on identical. So here, instead of, because the denominator is 72, I want the same denominator. So it's 72 over 72, which is 1 minus 20 over 72, which will give me 52 over 72. So if I reduce it further, I have 26 over 36. Okay, and then I reduce it further, I have 13 over 18. Okay, so we did a similar question yesterday. Yesterday it was counters. Today is sweets. I've found similar questions, so I'll be bringing them in the starter because I believe in repetition. The more you solve a type of question, assuming this came in the exam, then you can do it. Whether they say counters or sweets or whatever, you can do it. Whether it is 9 or 10 or 15 in the bag, then you can use the same principle to answer them. So tomorrow I have a similar question. I'm going to repeat it in the starter for you to see. Okay, so that is what I have for you in that starter question. So we'll just have a look at one of the exam question. This is also from a calculator paper, and then it's a past paper from a higher paper. Okay, now show that. So if they say show that or prove that, it means prove that this whole thing here, the left hand side of the equation, equals the right hand side of the equation. Okay, so I will start from the left hand side and then gradually arrive at this. Okay, this is algebra, so this normally comes. So I'm going to bring this out. Okay, if you look at this question properly, it's 3n plus 5 all divided by 3n minus n over n minus 1. So I need to show that I can reduce this to 2n minus 5 over 3n n minus 1. Okay, now, so if you look at it critically, okay, I'm going to start from the left hand side and work my way towards this. As I'm solving this, I'm looking at this. Okay, I wouldn't take my eye off this because I need to simplify and get exactly this. Okay, so now look at it. 3n plus 5 over 3n minus n minus 1. So I'm going to treat them like they are fractions, a numerator and a denominator. Just in this case, it is it includes variable. Okay, now 3n and n minus 1. The common factor here will be 3n into bracket n minus 1. Okay, so now 3n will go into 3n n minus 1. I'll be left with n minus 1. So in the numerator, I have n minus 1 times 3n plus 1. I'm putting them in brackets so that I don't get confused. Okay, so I'm treating them as if they are one x and y. But here I have n minus 1, 3n plus 5. Now this is my minus in between. So n minus 1 into this 3n n minus 1. We'll take the n minus 1 off. So I have 3n times n in the numerator. But here our minus affect everything 3n into bracket n. Okay, now if I simplify this, you remember yesterday we did some simplification. So n will multiply everything in the bracket, minus 1 will multiply everything in this bracket, the 3n plus 5. Okay, so n times 3n will be 3n squared. N times 5 will be 5n. Okay, minus 1 times 3n will be minus 3n. Okay, go and look at our algebra series. Minus 1 times 5 will be minus 5. That is just this part of the equation. Then minus 3n squared, which is that part, all over 3n n minus 1. Okay, now if you look at this equation carefully, we have 3n squared minus 3n squared. That can take care of itself, so it becomes 0. And 5n minus 3n becomes 2n. And then we have minus 5, all divided by 3n into bracket n minus 1. So now we've arrived at 3n. We've arrived at 2n minus 5, all divided by 3n n minus 1 into bracket. and that is what we are supposed to prove. So now I've proved that 3n plus 5 over 3n minus n over n minus 1 is equivalent to 2n minus 5 all over 3n n minus 1. Okay, so I've solved the equation. Guess with 1, 2, 3, 4 steps. Okay, everything I use here we know, because if you have a fraction 4 over 7 minus 3 over 14, you can do that. So you just treat this as a fraction. Start from your left hand side. As you look at this, the right hand side, what you are supposed to arrive at, simplify, take out what you can't take out, and then just continue till you get to your this answer. And then you've shown in the end, you say that therefore this is equivalent to that. Okay, so in fact everything you need for this, you have done them. It's nothing new. All you need to do is to take things step by step. And if you are not being distracted in the exam room and you focus on your paper, you can get a minimum of C or even more. Okay, because most of these things you've been doing them from upper primary, like year 5, year 6. They might not be as complex as that, but you know that like 5n minus 3n is 2n. You've been doing it for primary school. So whether it came in the higher paper or in the foundation paper, you are very well equipped to answer these questions. Okay, so yeah, tomorrow again, the starter I'm going to bring is similar to the question, the probability question that we are looking at. Okay, where in the back there are nice some counters or suites or whatever, and then we'll look at it again, and then we'll see, because if there's a probability question showing up, I don't want you to say I don't get it, so I won't do it. Okay, they are very easy. You just have to do it step by step. So I might bring a starter question again tomorrow that will involve probability, whether it is 9 in the bag or 10 in the bag or 7 in the bag or whatever number it is. You just have to listen to the question, read the question, and then apply the principles that I've shown you. Okay, and then you should be fine. Please subscribe, follow, like, and share. Okay, I appreciate it a lot. Thank you so much for watching our video today, and I'll see you in the next.